Welcome everyone. In case this is going live, this new studio here is slightly annoying. Also additionally pulls audio crashing, so I hope this time we are live and with audio, which of course was again pulls audio crashing because probably why not. And yes, on my other portable SSD installation it was running smoother, but that comes from anyway. Today's video I wanted to finally configure a ThinkPad because, as you see here, this old crap that I'm dealing with is not cutting it anymore. Of course, my main workhorse here, Retina MacBook Pro 15-inch, nearly maxed out from 2013 or something, mid-2013. And even that is not amazing anymore, but more to this in a minute. Otherwise, what I have since a couple of years for Linux testing on tablet size, the Surface. This was not an amazing choice, can't recommend, would not buy it again. And for so many reasons that you can watch my previous videos for, including lack of power as you see here, but also lack of ports and touch disease and stuff. Also wanted to pause this video. Anyway, so I wanted to now the video is running so much to double clicking here on this amazing pause button. So I configured here the ThinkPad because finally can't stand here all those failing live streams anymore and need something to get my work done, and certainly not butterfly keyboards in the latest generation. And something surprised me here. So first of all, I was looking here, Core i7 8565 that I selected here, and then 8565. Why is the frequency different? Why do they nearly charge €300 or dollar more? And then I did here some referencing. So I think here's a typo, but not on all of the listings, maybe only some Europeans. The US listing is actually correct. So this is not Core i7 8565, but this most likely is 8665, which matches here 4.8 gigahertz. The reason, so you have for 4.8, so 8665, so much to all the Intel SKUs that even the vendors list here, maybe sometimes wrong models. And last but not least, this is not everything. So then when you take a look here, this is supposed to be whiskey, like you, again, the amazing names, right? But also, I'm slightly wondering that this CPU here, Intel CPU 8565, is starting at 1.8, the higher performance 8665 at 1.9. I really wonder why they do not, for energy efficiency reasons, have the same base clock and just turbo more. Maybe this would lead to another 10 minutes or so longer battery life or whatsoever. A much more important point, or actually two, I wanted to make. So first of all, why do I look into the Intel SKUs? That is not only the display, which I would prefer WQHD or something for 150% scaling for a little bit more screen real estate and such. But the other point is they are slightly faster. And as I pointed out, especially as the Zen 2 silicon is most likely mobile silicon, of course desktop, to be released in a week time or so. And this is probably what I will upgrade our mini ITX nodes, test nodes there in the office. Hopefully we get a BIOS update for this Asus whatever mini ITX. So we will test the desktop stuff, certainly with double the core count and certainly much upping here the 65 watts that we have in the office to 100 something watt, maybe undervolt a little bit or whatever, at least double the core count for our massive parallel, not only machine learning, OCR and stuff, you name it, but also certainly T2 compilation. So due to this, unfortunately, most likely I will have to get this Intel SKU here. But then the much bigger note is that when you compare this, so I compare here this two CPUs because I wanted to see what do I get when I pay here nearly €300 extra. What do I get for this? And to my surprise, this is where last year when we struggled with the dual channel AMD ThinkPad stuff, to get actually more performance due to dual channel. I think in this comparison here with Geekbench of all benchmarks, I think with this two SKUs here compared just some two random Lenovo stuff here with just those CPUs, this is Core i7 8565U versus 8665U, just exactly what we were talking about, 2 GHz, 2.1 GHz, probably is this base clock or somehow does not match entirely, but whatever. Anyway, so first of all, this is also slightly wrong here. Something misclassifies this here with Whiskey Lake versus Kaby Lake. According to Wikipedia, they should both be Whiskey Lake, quad-core 40 nanometer, but whatever. And so yeah, somehow those names here, sometimes you see even others don't really quite get those bloody code names right, but whatever. I think you see here dual channel versus single channel or something of that sort, because on this side, so this should be the slower, right? So this is a 8565, and this is also the node when you spend so much more money, not only on ThinkPad, but wherever Intel, not Intel, Apple, famously commonly known for thermal throttling quite a lot. And yeah, so much to even here, I spent, this probably was the most performant SKU back in the day when I ordered this soon 5 years ago or whatever. And so yeah, and then it's thermal throttling, right, just with a Core i9 or whatever. And you see here, you do not necessarily get so much more performance out of this. So actually less here in those two benchmarks, just a little bit. And the reason for this, I'm pretty sure most likely is memory configuration. I guess it should be, because you see here all the benchmarks, all the small benchmarks, single core benchmarks, they are all just a little bit faster here for the most part. And then with memory significantly slower here, 2 GB per second. So my opinion, most likely, or even memory latency, whatever. So my opinion is most likely can only be single versus dual channel memory configuration or something of that sort. And there you see, if you spend so much more money for Intel SKUs, you might not necessarily get the performance there. And the other note is also, I mean, the whole stuff is completely bananas, right? I'm really not a fan of Intel naming everything Core i7, because here in this surface I also went with a more expensive, higher performance Core i7, which, as you see, is not that much performance. And this is my grief, not only with the stupid code names, Kaby Lake, Whiskey Lake, Hare, whatever, I'm really not a fan. Also the same with macOS namings, right? El Capitan, Mavericks, Sierra, High Sierra, and now Catalina, whatever, something. The problem with the naming is you do not know what comes first. You have a random set of names, and even after 2 years, you even forget. With macOS, do you think I want to fill my brain with code names of macOS? So the same code names, annoying. And also Core i7, I really wish Intel would not name everything Core i7, because you see, you cannot just choose something with Core i7. Core i7 can either be ultra low voltage tablet stuff that can do nothing, and you see how sluggish, even if I'm not running OBS for this video encode here, everything is slow and hard to use. But even then, and this is also my grief with also Firefox and Rust, I'm not making this shit up. This Core i7 here from a couple of years ago, just 3 years or whatever, it's completely unusable with modern web stuff. Everything is slow and sluggish and annoying. And last but not least, when we compare this, in this comparison here, I have configured just this MacBook Pro 15-inch Retina late 2013. What I have here the, at that time, most likely highest SKU Intel Core i7 4850QH HQ, 2.3 GHz, and 4 quad-core 8 threads. And there you see not so much actually has changed. And there you see how much more performance would I get? Well, I would get a little bit performance, but this is 5 years, or 2013, 14, 15, 16, 17, 18, nearly 6 years soon, plus minus or whatever. So in 6 years, what do we get? And when you take a look here, well, not so much. Well, single core is quite significantly faster, some 25% or something. But hey, 25%, right? And this is for a top-of-the-line ThinkPad. Well, there are the higher performance models, but otherwise top of the line. And when you take a look at this here, this L1 cache, L2 cache is the same. The only thing larger is the L3 cache. And well, of course, the microarchitecture. And the biggest difference here, of course, this is comparing apples to oranges, but this is also pointing out this trend of thin and light is exactly what is getting us into that, because this is comparing here some 15 or so watt part. So this was 45 watts, I think, and this here is 15 watts. However, this is also up and down configurable. We could actually take a look at this, how much is this. So yes, this is slightly comparing apples with oranges. And of course, we are a huge orange fan. But it's just what, well, unfortunately, in my opinion, the vendors, of course, say, yeah, the market demands this. In my opinion, the market does not really demand this that much, because no user is asking for, hey, give me less performance for a higher price or something. If we take a look here, most likely this is 15 watts is, of course, misleading, if not lying. For sure, this is a very huge configurable design. What configurable down? So this is even down configurable, as you may or may not see with this video. Screen cut here of this. Even this has WQHD something screen here. So this is down configurable to 10 watts, up configurable to 25 watts. So I only hope that Lenovo is using their higher wattage on the higher end ThinkPad models, but this is also my grief with information policy of the vendors. Well, for one thing, they even have a typo here in their listing, and for another thing, they don't even write here what is their performance configuration, because you see, you cannot just buy this Intel CPU and expect performance X. You can expect anything from 10 to 25 watts or something, which is a little bit hilarious in my opinion nowadays. So anyway, last but not least, in the other video, I made a video here about the upcoming Ice Lake. But the problem is I need now something, because neither this nor this, neither the Apple nor the Microsoft is here usable anymore with modern web, Firefox, and you name it, and all the Intel security mitigations. And so I made this other video with Ice Lake performance, and what have they done? I proclaimed that mostly they just doubled all the buffers and caches, stupid. And you might think, some people ask me, when they doubled all the caches, you know, the caches now whopping huge megabytes. Was it written here somewhere? But they wrote here double of the T2 cache. They also doubled a lot of other buffers. Maybe this site actually was not the best to quote for this other time. We had Wiki CPU or something. Anyway, why is the performance not double then, you might ask? And the thing is, come on. The thing is, of course, that before the caches were already super large. When you compare this to 486 Pentium, we only had 8K or 16K, and of caches, 256K of L2 cache and stuff, not even a L3 cache, and so on. There's even the website now. This is when you want to Google, here is something, wiki chip Ice Lake, maybe this. And because the caches were not so inefficient, of course you have a cache hit rate of already, let's speculate here some numbers, roll some dices. You might have with the current generation or last year's generation, you might have with, and again, this cache is already super large, right? Maybe the L1 cache rate is 50%, the L2 cache rate is 80%, because you have always inner loops of multimedia software of your browser, Java, just-in-time code running and stuff. And because the cache rate is the hit rate, the efficiency of the cache is already maybe 50-60% for L1, 80% for L2, and then you have L3 cache. This is already the L3 cache maybe 90%, 95% efficient. If you double all the caches, you do not double your performance. You only gain on the L1 cache maybe 50-60%. You gain there maybe 40-50%, but not even this. Of course, you double this, you do not get 100% cache hits, so you only get like 20% more cache hits if you double the L1 cache. And then the same for the L2 cache. Maybe if you have 80-90%, let's 80%, you see this is where the 18% IPC improvement comes from, because from just doubling all the caches, stupid, you do not double the performance. And this is what we see here in the benchmarks and 18% IPC. And this is also not exactly the page I was looking the last time. Anyway, I guess you get the idea, and hope you learned something. And I wish the vendors would make more amazing choices, because as you see, when I spec out this ThinkPad here, and yes, it is cheaper. So when I spec out the ThinkPad for maybe like approaching $2,000 or euro for my professional IT needs here, including not only source code editing, but also occasional once or so every day live streaming is something, of course, a relatively high end, but I do not gain so much compared to my aging 6-year approaching Retina MacBook Pro. So yes, I could get the performance model, but of course it is way thicker, and I might even make this compromise, but it only has NVIDIA graphics. This is why I will not get this. So yeah, performance wise, yeah, still when you wonder why have I not put the trigger and purchased something, yeah, there's always something, right? The AMD ThinkPads don't have the most amazing displays. It is not Zen 2 but Zen 1 Plus, and the Intel models, yeah, 15 watts. So there were improvements, but they were mostly for the consumer parts passed on in terms of energy efficiency, which, yeah, of course this only when it was new had 5 hours battery life. The new ones have 10 hours battery life, but I would also really like to have a little bit more performance. And do not get such tablets here, even for web browsing, they're annoying. And this is here Core i7, so even if you buy something like this Chewy or what it's pronounced, ultra portable thing there with some Core M3 dual core or single core with hyper-threading or whatever, the performance is, yeah, I really wonder what you want to use it for, if not occasional VI text editing, and certainly browsing the web is, yeah, probably as performant as browsing the web here with OBS running. Anyway, this is why we are where we are. Intel didn't have so much competition, innovated mostly on efficiency, not really that much on performance, and this is why in 2019 we sit here with laptops that can barely browse the web anymore, and vendors having, well, options that may satisfy some student but not the IT pros. Let's see, hard to watch. What is hard to watch? Hello everyone, what do you think about the new Raspberry Pi? What do you mean with hard to watch? Is the stream that crappy? At least we have 0 drop frames according to my OBS. I hope the audio wasn't that broken. It should run 48. So yeah, Raspberry Pi, comments in the audience. Of course, performance-wise, Raspberry Pi latest one should be more performant, but there were already more performant versions out there, and yeah, dual display and such. Maybe I make a dedicated video about this to point out the details. I only had the Raspberry Pi Zero for embedded stuff, tinkering, that I made a brief video about last year, because I was not the greatest fan of the Raspberry Pi performance, and some ports like Serial ATA, maybe what was with Ethernet, I forgot, and stuff like this. It's Superscalar now, so it's probably vulnerable to Spectrum Meltdown. Something that would be fun. I hope the stream was not too broken. If it was too broken, there you see I need a new machine, because again, why do I not live stream from this? Because what I said in the beginning of the video, we could also finish with this conclusion. Do not get a Mac Back in the day, they were at least somewhat more amazing, but even then, NVIDIA graphic not amazing for Linux, and then the Graphic Mux also not amazing. It works a little bit, but still not fully. And if I boot here Linux, I first fiddle around disabling NVIDIA, booting with Intel only, which again you need trickery for, EFI trickery, EFI magic, because Intel otherwise, not Intel, Apple is otherwise hiding the iGPU from you, which is a really dick move from Apple. The new Macs I can't buy for all the soldered SSD and crappy keyboard reasons, dust stuck and whatnot, not upgradable and not Linux friendly, even less Linux friendly. And then on top, binary only Broadcom Wi-Fi here on this model, really piece of garbage. And then when I boot here, the latest problem is at least it has 2 USB ports, which I would also not buy something. Well, at least this has 2 USB ports, well, and 2 Thunderbolt, but old-fashioned Thunderbolt. Anyway, this bloody Thunderbolt does not help me much here on the go. And then latest stuff, when I boot here, the external SSD, which I usually use, you have seen here me, this portable SSD that I just plug in everywhere and boot and run here for all the Linux desktop goodness. My latest problem is that some machines, maybe that's a new Linux kernel issue, I don't know. I didn't really have the problem that much in the past, that sometimes I lose the USB connection. That certainly is really annoying for your root file system going away, especially maybe it has to do with this HDMI grabbing stuff. Maybe this is just USB being USB here, and then with high throughput there of HDMI capture, then the USB subsystem goes nuts or something, not really diagnosed. I didn't have the problem in the past. This is a new issue. Maybe it's new, but I think I had a similar issue on both the Surface with the USB hub as well as the Retina MacBook Pro, and then I need to boot the old kernel for binary only Wi-Fi, and nothing is amazing, and it doesn't help me much. Yes, the Surface is also overheating, thermal throttling and dock slow, but it helps me a shit if my USB devices disappear and I need to fiddle 15 minutes to get this booted with NVIDIA disabled. Again, huge trickery. If I don't do trickery, I only have NVIDIA graphic, which is complete garbage in Linux with Novo or Nuevo. At least it works a little bit, but it's garbage. And then, so this is why I need the trickery, with the basic trickery with patched grub2, which of course I have patched, and boot the patched grub2. Then I have both graphics, which only helps me a little bit because the Mux switching doesn't work. So this is like basically no effort tinkering because I have this set up, but then I have dual graphic, Intel and NVIDIA. This is bloody Apple Graphic Mux, and this also does not work flawlessly in Linux. This is why I need additional 10 minutes of trial and error, because I use a NVRAM variable setting here to notifying the Apple EFI BIOS to run Intel only. This is possible. There is an EFI variable for this, just it does not always work. So I boot, I set this variable, I reboot, it doesn't work, I set it again, I reboot, it doesn't work. Sometimes I reboot 15 minutes until I have a state where I'm in Linux with Intel only, and say, you see, don't buy this Apple crap, completely cannot recommend this. Really need to get a ThinkPad. Long story short, the year of desktop Linux you have seen, otherwise it works amazing on the Mac Mini. Well, mostly otherwise AMD Ryzen ThinkPad, new ThinkPads, AMD ThinkPads, AMD Ryzen build, everything is amazing, just not this old garbage here. And don't buy ultra low voltage tablets, not MacBooks, can't recommend. I hope you learned something. So I do not know all the small board. I mean, the Raspberry Pi is mostly fine, of course. And the pro thing of the Raspberry Pi is, by the way, I hope I didn't touch the USB cable enough. Yeah, we still have audio. The good thing, of course, with the Raspberry Pi is you have this compatibility. If you use any other small board computer stuff, then you may need to fiddle around more. So that is. It's a slideshow, really. Okay, sorry for that. I thought it's anyway. Surface overheating, whatever. Anyway, it's a podcast. Yeah, as you see, getting a ThinkPad, so probably the rest of the year, it should be more amazing, I hope. And Yeah, RISC-V, that is how different is RISC-V from ARM. So RISC-V is entirely different. I made a video about this. You can watch probably like 2 weeks ago. I made a RISC-V instruction set architecture video that is a basic overview. So basically all the instructions are entirely different. So you need to recompile everything. It's like zero compatible, but RISC-V is pretty cool and amazing. I hope it's the future. So probably in 5 years time, maybe even already in 2 years time, many SBC boards will be RISC-V. So if you want to get into something new, RISC-V is certainly a nice thing right now, but right now there's only very low performance RISC-V stuff, but certainly more high performance stuff is coming soon. And easier to learn for beginners. Yes, I think RISC-V is much easier to learn. Watch this video, the instruction set architecture. Well, first of all, if you program in C, C++, with the Linux kernel, you don't really touch much, so you don't really need to learn anything for the most part. And if you go into low-level stuff, then RISC-V is much, much easier, in my opinion. You can watch the other video. ARM is relatively complex. ARM is not a Z-reduced instruction set architecture. Maybe I should make a dedicated video. By the way, as always, leave in the comments below what videos and topics you would want to watch. ARM is relatively complex in that it has conditional flags for a lot of instructions, which is pretty cool. So you can usually have like an add or move, I think just for memory. Some details might be off, but whatever. You don't have this with MIPS or x86. Conditional means you can flag many instructions in ARM to only run with some comparison, if like 0 compared to 0, if whatsoever. So this ARM is one of the more complex instruction sets. It's not as simple as MIPS or Spark. And RISC-V is much more simple, at least right now, and pretty cool and modern. And yeah, watch this video. I think that's it for today. We have 0 drop frames from the few frames encoded or something, and yeah, need to order ThinkPad. Leave me in the comments below what you think about all the Intel Core code naming, Core i7, everything. So yeah, Core i7 from this ultra low voltage piece of not fast running garbage to enthusiast workstation, Core i9 stuff, not amazing, and otherwise code names. And yeah, otherwise leave in the comments below, do you want to see programming videos, assembly in ARM? Of course, we have plenty of ARM boards. We have a Raspberry Pi